Hi friends, my name is B.K.N.V.Visweswara Rao. If you wish to see all my videos in my channel, please write down Bosam Rao, B-U-S-A-M Bosam R-A-O Rao in YouTube search engine, and you will get my channel instantly. Now I wish to describe about low vacuum files. In my previous video I described low vacuum files, and now I am going to discuss the calculation part in the low vacuum file. Say for example a machine which is producing 20 ton per day to 20 ton per hour draw rate, which head box consistency may be 0.4 or 0.6, but the number one low vacuum file inlet consistency is 1.4, let us say. That we can change according to our value. We can make it 1.6 or 1.8 to 2, like that. Leaving consistency is 3%. Leaving consistency is 3% from the first file. And a vacuum maintained in the low vacuum file is 400 mm water gauge. Number of droplets 3. And height of the droplet, because water column, so 400 is the the draining water itself form as a column, so 400 height is enough. And the diameter of the droplet calculated as 200 for number 3. For 3 numbers droplets, 200 dia is required to drain the water which collected from 1.2 consistencies to 3% at a 20 ton draw rate. Similarly, for the number 2 vacuum file, inlet consistency is 3%, because number 1 vacuum file leaving consistency is nothing but the inlet consistency of number 2 file. And outlet consistency, say for example 6.5%, then the vacuum maintained 600 H2O, and the number of droplets are 3, and height of the droplets is 600 and the diameter of the droplets is 108 that is 4 inch nearly. So 4 inch pipes 3 is required for draining all the water collected to enhance the consistency from 3 to 6.5, and this water collection at the draw rate 20 tons. So like this we can understand how to calculate the diameter of the drop leg. Say for example it is a machine making 10 tons production, then let us see what will happen. And instead of 200 it has become 140 3 droplets, and 400 is the length. And for example if it is and similarly 77 here, instead of 100 it has become 77 for 3 droplets. And here say for example the consistency, leaving consistency, inlet consistency is for example 1.8, then drop leg is 94. Drop leg has calculated as 94 that is 100 4 inch. Instead of 5 inch it has become 4 inch to make the head of 400 because this is also a water. The water column draining through the drop leg is equal to the of water column maintained by the vacuum blower. Similarly, say for example if it is 2 tons draw rate, let us see what will happen. 2 tons draw rate, 2 tons and enter. And if it is 1.8 to 3%, 1.8 to 3% consistency enhanced, and according to the quantity of the drained water, the droplets are 3 droplet size is 42 mm. That we can say we can reduce it to 2, then it becomes 52. If we have only one droplet, let us see what will happen. Then it is 3-inch line. 3-inch 400 mm line is required to drain all the water which collected from 1.8 consistency to 3% consistency. Similarly here also, number 2 vacuum, 3% is the, and if we say it is 5%, 5.5 will say 5.5, then what will happen? 31 mm, and 600 mm is the water column. Like this, we have to establish the low vacuum foil for better drainage and good sheet consolidation. This will improve the performance of the paper machine. So everybody aware of these things. Every paper maker must know, every designer must know before supplying this low vacuum foil. So hope enjoying this video. Please subscribe, comment